Understanding encryption, how it protects your network. Understanding encryption, how it protects your network. In today's world, electronic communication has become an essential component of both our personal and professional lives. We send and receive sensitive information daily, including financial details, business transactions, and personal messaging. Unfortunately, cyber attacks and data breaches are prevalent, and they can result in the loss or theft of this information. Encryption offers users a powerful tool to protect their networks and sensitive data. In this article, we will attempt to demystify encryption and how it can protect your network. What is encryption? Encryption is the process of encoding information in such a way that only authorized parties can read it. It involves converting plain text into ciphertext using a complex algorithm. Only the intended recipient can decipher this information and revert it to its original plain text form. Encryption is an essential tool when it comes to protecting information from unauthorized access. While encryption has been around for centuries, computer encryption is relatively new. The earliest examples of cryptographic communication date back to Julius Caesar's time in ancient Rome. Julius set a simple substitution cipher by shifting each letter in the alphabet by a fixed number of positions. Today, we have more sophisticated cryptographic systems that can encode data at much greater levels of complexity. How encryption works. Encryption relies on two things: the encryption algorithm and the key. The algorithm is the set of rules that determine how the original plain text message is converted to ciphertext. The key is the secret that allows authorized individuals to decrypt and read the message. The encryption process involves converting the plain text message into a binary format consisting of zeros and ones. It then goes through a series of complex mathematical functions that convert it into ciphertext. When decrypting, the process takes the ciphertext and reverses the mathematical functions to reveal the original plain text message. Keys are essential in encryption because they allow only those with a key to decrypt the encrypted message. Keys are essentially a set of random characters that are generated for each message. There are two types of keys in encryption: the public key and the private key. Public key encryption. Public key encryption is also known as asymmetric encryption because it uses two different keys for encryption and decryption. With public key encryption, the receiver generates a pair of keys, a public key and a private key. The receiver shares the public key with the sender. The sender then uses the public key to encrypt the message, which can only be decrypted using the receiver's private key. This process is the opposite of a private key encryption, where both sender and receiver have the same secret key. Private key encryption. Private key encryption, also known as symmetric encryption, uses the same key for encryption and decryption. In this case, the sender and receiver share a secret key that they use to encrypt and decrypt messages. Private key encryption is faster than public key encryption, but it is not ideal for sending messages to multiple recipients. How encryption protects your network. Encryption is essential in ensuring the privacy and security of your network and the information transmitted over it. When data is encrypted before being transmitted over a network, it becomes unreadable by anyone who intercepts it. Only the intended recipient can read and decrypt the data using the appropriate key. Encrypted data also protects against unauthorized access to network devices and services. For instance, administrators use encrypted communications to log into network devices like switches, routers, and servers. Without encryption, an attacker could easily intercept the administrator's login credentials, allowing them to gain access to sensitive network resources. Encryption is also essential when it comes to securing wireless networks. When you use Wi-Fi to connect to a network, your device and network use encryption to establish a secure connection. This ensures that your connection is protected from eavesdropping and other forms of interception. However, you need to ensure that you are using a strong encryption method, such as Wi-Fi protected access to WPA2 or WPA3. Encrypting data at rest. Encryption is not just limited to network transmissions. Encrypting data at rest refers to the process of enciphering data that is stored on a hard drive, flash drive, or other storage medium. Encrypted data can only be accessed by someone with the appropriate key, ensuring that sensitive data remains secure and private. Encryption is the perfect form of defense against data breaches, where attackers gain access to stored data. Even if an attacker manages to steal encrypted data, they would still need the appropriate key to decipher it. Without a key, encrypted data is effectively useless. Potential risks of encryption. While encryption is an important tool in protecting your network, it is essential to remember that it is not foolproof. There are potential risks that come with encryption that users should be aware of, including 1. The security of keys. Keys are the critical mechanism in encryption. If an attacker gains access to the keys, encrypted data becomes vulnerable. It is essential to ensure that your keys are protected at all times. 2. Endpoints. Encryption is only effective if both endpoints use secure protocols correctly. If one endpoint fails to use encryption, data can be exposed. 3. Quantum computing. Encryption algorithms might be susceptible to attack by quantum computers. Some algorithms used today may become obsolete in the future. Final thoughts. Encryption has become increasingly important as cyberattacks and data breaches continue to occur. It is vital for individuals, businesses, and organizations to understand what encryption is and how it can protect their networks and sensitive data. By converting plain text into ciphertext and using a key to decrypt it, encryption ensures that only authorized parties can read the information. There are two methods of encryption: public key encryption and private key encryption. Public key encryption uses two different keys for encryption and decryption, while private key encryption uses same key for both processes. Encryption protects networks by ensuring that data transmitted over them is unreadable to anyone who intercepts it. This prevents unauthorized access to network device. And services, protecting sensitive network resources. In addition to network transmissions, encryption can also be used to protect data stored on a hard drive, flash drive, or other storage medium. Encrypting data at rest ensures that sensitive data remains secure and private, preventing it from being accessed by unauthorized parties. While encryption is an essential tool in protecting networks and data, it is important to be aware of its potential risks. The security of keys is crucial in encryption, and if an attacker gains access to them, encrypted data becomes vulnerable. Additionally, encryption is only effective if both endpoints use secure protocols correctly, and some encryption algorithms may become obsolete in the future due to advancements in technology. Taking the time to understand encryption is crucial in today's world, where electronic communication is almost ubiquitous. Encryption can help protect sensitive information that is transmitted over networks or stored on devices from unauthorized access by encrypting it using complex algorithms and keys. As previously mentioned, the earliest examples of cryptographic communication date back centuries. Over the years, encryption has become much more sophisticated. Today, encryption is a standard mechanism that can effectively protect against attacks.